Okay, we like this function. Imagine if there were another function. Okay, imagine there were another function. This function, very different to copy array, multiply by 2, copy array, divide by 2. We're in, copy array and add 3. Copy array and add 3. We're going to build a brand new function for it. No, we're not. All right. What principle are we breaking, Z? What principle are we breaking by building out each of these functions?
Do not repeat.
Yeah, dry principle, right? Don't repeat yourself. We're breaking it profoundly. Everything's the same. Copy array and multiply by 2. Take in an array, create a new output array, loop through the input array, take each element, do something to it. The only thing that changes is what is the only thing that changes, Lewis?
The functionality that you're doing to the element.
To the individual element. The operator and the operand, the individual thing, the functionality we do to the individual element. And yet we're building out entire new functions, copy array and multiply by 2, copy array and divide by 2, copy array and add 3. We're building out all that functionality, but the only thing that's changing is a little thing we're doing to the individual element. Philip, can you think of a better way of doing this? Can you think of a different, if we think back to our function 10 squared, 9 squared, 8 squared, 105 squared, is there a better way you can see of, rather than building out brand new functions, what could we do?
Sure, we could generalize it more.
We could generalize it. How would I do that? You say, to make it reusable, but how? Because I can't just go about, like, passing, well, give me more details.
Give it another parameter.
Another parameter. So you're saying build one general function, we could call it copy array and manipulate, and then leave a placeholder parameter for when we run that function, fill that place or that parameter in with the specific functionality plus 3, divide by 2, multiply by 2 that we want to have applied to each element. Okay, but how would we pass that in? Could we just pass in, plus 3 like that to apply it inside? Is that legit?
No, we can't do that.
We can't. So we could imagine a language we could, but in JavaScript we definitely can't just pass little bits of functionality around and leave placeholders. It'd be lovely to leave a placeholder and pass in the plus 3 when we run copy array and do something, manipulate, let's say. But we can't do that. How do we wrap up functionalities we pass around in JavaScript, Z?
In a callback?
More intuitively.
In a function.
It's in a function, yeah, as you rightly say, Z, like in a function. The only way I can pass functionality around in JavaScript would be to get rid of the plus 3 and actually pass in, leave a placeholder for some functionality represented as a function. And that's what we're going to do. That is exactly what we're going to do. We can generalize our function that we pass in a specific instruction only when we run the copy array and manipulate. So we can build a brand new function called copy array and manipulate, and when we call that function, when we run that function, when we invoke that function, at that point we can pass in the specific functionality. But we're going to represent that with these instructions. So just like array becomes 1, 2, 3 when we run copy array and manipulate, so too instructions is going to become multiply by 2. We're going to end up with multiply by 2 grabbing the individual element of the array as an input to multiply by 2, taking the array position 0, which is 1, and throwing it into multiply by 2 and returning out 2, achieving the same as when we had array position 0, number 1, multiplied by 2. We can't pass in multiply by 2. All we can do is pass in some functionality and then have the array position 0, the number 1, thrown in to that functionality and then returned out. We sort of flip it on its head. So we're going to leave a placeholder so that we can just have one copy array and manipulate function and then have a placeholder not only for our data to be filled in with actual data 1, 2, 3, but also for some of our functionality. We're going to have some of our functionality, in this case, the thing we do to the individual element, also left unknown, left blank, until we run copy array and manipulate. And at that point, we'll figure out what's instruction's going to be. We'll figure out what's going to be. All right, we're going to walk through this very precisely line by line so we truly understand it. This is the last of our callback and higher order function code. Here we go. So, line 1. Skylar, what are we doing in line 1?
So we're declaring a function copy array manipulate with the parameters array and instructions.
Copy array and manipulate. Copy array and manipulate is a whole function definition sort of memory. But we're not done yet. Z, what's our next line of code say to do?
We declare the function multiply by 2 and store in global memory.
Multiply by 2, and it's a little baby function, little tiny function, only going to take in a single element, hopefully. I'm going to multiply that by 2. So we have a big function, copy array manipulate, a little baby function multiply by 2. Excellent. Next line, Lewis.
We're declaring a variable called result,
All right.
setting equal to undefined until we invoke copy array.
Until we get the return. I would say rather than until we invoke, even as we're invoking it, it's going to be undefined until we get the return value from the call to copy array and manipulate. Copy array and manipulate, and this function is taking in what as its first argument, Lewis?
The first argument is an array containing 1, 2, 3.
Okay, perfect. And the second argument, Lewis, is
the function definition multiplied by 2.
aha, the whole function definition of multiply by 2. Huh. So it's the whole function, we're grabbing the whole thing. So just like inside this copy array manipulate, array is going to be replaced by 1, 2, 3. Wherever you see array inside the body of this function, no longer. It is going to say 1, 2, 3. JavaScript is going to replace it, pull it out, and replace it with 1, 2, 3. Similarly, wherever you see the word instructions inside of there, JavaScript is going to grab out those instruction placeholder and say, it's going to replace the whole word instructions with the words multiply by 2, because 1, 2, 3 is filled in array and multiply by 2 is filled in instructions. And so wherever you see instructions inside of this function, it's going to be switched out for multiply by 2, meaning we're going to see something like multiply by 2, parens, multiply by 2 being run with the input of array position 0, 1, multiply by 2, input 1. We're going to get there in a second. Okay, so we're calling a function, copy array and manipulate. We know its output is going to be stored in the global variable result, but we've now got to execute this function. So everyone together, we create a new
Execution context.
Okay, that was very in sync, very good. Excellent. All right, new execution context, very important thing to remember. And say in chorus. Good, so into it we go. And it has a local memory, and our thread wends its way in. Okay, into the local memory, we will be storing first our parameters and arguments, or parameters with their associated value of the arguments. So Z, what's the first thing that goes in the local memory?
The first parameter is array, it declares array.
Yeah.
And it's going to be the array 1, 2, 3.
Perfect. All right, and the next one, Philip?
It's going to be instructions.
Uh-huh.
And it's going to be set to the value of multiply by 2.
Perfect. The function definition of multiply, with the previously had the name multiply by 2, it's just the function definition. This whole function definition, previously known as multiply by 2, not inside of here. It was known as multiply by 2 inside of here. Now we're going to refer to it as instruction. So to be clear, Philip, if I wanted to run the functionality formerly known as multiply by 2 from out here inside a copy array manipulate, what label could I use for it?
I would use instructions.
Instructions. And I know, and so if I wanted to run multiply by 2 with the input of 3, what would I write?
Instructions parens 3.
Because this really is multiply by 2. It's going to be switched out for JavaScript in its mind and switched with multiply by 2. With parens on the end. Okay, perfect. All right. Next line of code, Lewis.
We're declaring a variable output, setting it equal to an empty array.
Perfect. Empty array output. So, we have outputs empty array. Array is 1, 2, 3, and now we hit the all-important moment, the body of the for loop. Okay. I has the value of what the 0th time we hit the body of the for loop. I has a value of what, Skylar?
0.
0, perfect. So I has a value of 0, so array index 0 is what, Philip?
1.
1. So we take that 1. Array index 0 is going to be switched out for the value 1. What is instructions being switched out for the value of, Philip?
Multiply by 2.
So we've now got multiply by 2, parens 1. So we've got to create what, Philip? A new
Execution context.
A new execution context for instructions really multiply by 2 with the input of 1. So we've got to create a new execution context for it. Oh, and we need to keep track of these on our call stack. So there's our copy array and manipulate. We were currently in that, but within that copy array and manipulate, we're going to call instructions. So it gets put on the very top of the call stack. Instructions with the input of 1, and that's where we are at the moment. That's where we are at the moment. Okay, and into it we go. And what we're really doing when we run instructions is running multiply by 2, so our input of 1 is being thrown into instructions, really multiply by 2. So what, Lewis, is the first thing in our local memory of this instructions really just multiply by 2?
So our parameter input is going to be 1.
Perfect. Input, so we look to multiply by 2 and see what is that 1 being thrown in to replace? Input. So we get input is 1. And then, Lewis?
And then we're going to return input times 2, which is 1 times 2, which is 2. And that's going to be returned to the execution context of copy array and manipulate.
Perfect. Return 1 layer out to the execution context of copy array and manipulate. That is to say, multiply by 2, input of 1, that whole little section of code is going to be switched out and replaced with the return value of running multiply by 2 with the input of 1, which is 2. And so this whole portion here will be replaced by 2, the return value, and that 2 gets pushed to the output array. Okay, and this execution context, Skylar, what happens to it?
It goes away.
It goes away, we pop it off, but it's a for loop, and so we go back inside the for loop, and this time the value of I is what, Philip?
1.
So array index 1 is what?
2.
And we do what with that 2?
We pass that to instructions, or we pass that to instructions.
Which is really?
Multiply by 2.
Okay, so we create a new
Execution context.
We pop off the last one, forgot to pop it off, but we quickly add back on another one. Instructions with 2. In we go, and what's the first thing, Philip, in our local memory?
Our parameter input is set to 2.
2, perfect. We do 2 by 2, which evaluates a 4. We return out that 4, which is the output of running instructions with the input of 2. We return out that 4 and store it, push it to where, Philip?
The output array.
Perfect. So our instructions really multiply by 2. Input 2, which is array at position now 1, which is the number 2. 2 goes in to multiply by 2. Instructions really multiply by 2. And that multiply by 2 input of 2 returns out 4. And that 4, that whole block, the running of instructions, the calling of it with the parens, which is really multiply by 2 being run, the whole thing gets switched out with a return value, which is a number 4. And that 4 gets pushed to output. But it's a for loop. No, I'm not going to do it again. There you go, 6. 2, 4, 6. And now we hit the final line of the function z. What's the final line of the function say to do?
Return output.
Return the value of output, which is 246, into the global variable result. There it is, 246. And we have achieved the exact thing we did with our copy array and multiply by 2. We've achieved the exact same thing, but we create a brand new function called copy array and manipulate. And then we left blank what exactly we were going to do to each individual element. We left a placeholder for the specific instructions we were going to do. And copy, array, and manipulate, when we passed in 1, 2, 3 and the specific instruction multiplied by 2, kind of live dynamically became copy, array, and multiply by 2. So we took in 1, 2, 3 and returned out 2, 4, 6. We achieved the same thing as copy, array, and multiply by 2, but we never specified in copy, array, and manipulate, this will do multiply each element by 2. We left it blank what was going to happen to each individual element. We left a placeholder for it, and then threw in, only when we ran copy, array, and manipulate, the specific instructions we're going to apply to each individual element.